Thank you, Simon. It's great to be presenting for this Gemini call. I'm just going to share my screen here real quick.
It's just coming through.
Perfect.
We can see it.
Hello, everyone. Our strategy for building digital twins is based on rapid scalability while generating business value. My name is Timothy Stahle, and I'm an IT project manager at Akademiska Hus. Our company, Akademiska Hus, is a Swedish government-owned real estate and property management corporation that owns, manages, and develops university buildings and campuses in Sweden. Currently, we've created a digital twin of 3 university campuses. That's Örebro University, Gävle University, and Umeå University. For some reason, Umeå University isn't showing up here in the PowerPoint. Anyway, and this amounts to approximately 400,000 square meters of external gross area. We expect to nearly double this amount by the end of Q1 2023. There we go. We have a pragmatic philosophy for building digital twins based on simplicity and scalability. Not to be too stereotypical here, but being Swedish, I like to use the IKEA example. So you can compare our philosophy to the IKEA approach, where we start simple, but we can scale endlessly, adding on additional business value as new business needs emerge. Our method for building digital twins is based on 2 core principles. We say that our digital twin must be a geometric digital representation of a building or property. Second, we need to make this digital representation connected to a network, giving us information about how the building or property is affected by its environment. We build our digital representation using CAFM data and integrating it with reality capture data to create a structured 3D model. Then we use our IoT platform to create the connection using various dynamic data sources like sensor data from space utilization, building management systems data, and scheduling systems data. We achieve high-speed scalability by LiDAR scanning first and creating BIM later. Reality capture technology gives us a very precise and detailed geo-referenced digital inventory of our buildings. These models are an excellent foundation for creating BIM in later stages of the building's life cycle, so for future reconstruction projects. So we can use these, so by LiDAR scanning first and creating a digital twin, we can add on BIM at later stages of the building's life cycle, leaving us open to using new potential modeling technologies that future markets may offer. This approach helps us avoid getting bogged down by managing proprietary BIM formats. This gives us a high-speed capabilities for producing scalable digital twins that provide value for us and our customers, while leaving us open to adding on additional complexity over time. Now, you're all probably wondering the million-dollar question. So how do we generate business value? Well, we primarily generate business value through using space utilization data for better real estate development and better energy management. Understanding how people use the space in our buildings gives us insight into how utilization and space can be optimized. One example is conference rooms. By integrating our model with our tenants' conference room scheduling systems, it gives us insight into and helps us identify rooms that get booked but not used. This insight helps us collaborate with tenants, enabling them to change behaviors, resulting in a reduction of or an optimization of space utilization, or it can help us as a building owner reconfigure floor plans to optimize the utilization or optimize the space itself. These optimizations can ultimately result in the reduction of production of new buildings, resulting in reduced real estate costs for our tenants, while also helping us both achieve sustainability measures. We estimate that we can, with the help of sensor data, reduce the need for space by up to 30%. But we can also improve the entire experience of the space. The user data provides valuable insights, which helps us understand what our tenants appreciate about the space and what can be improved. In one example, we analyzed user data from over 10,000 rooms. This data was the foundation for conducting interviews with a user group, giving us insight into what they appreciated about the space. In this example, these interviews helped our real estate developers understand what users appreciated about the space. And in this example, it showed that users preferred space with more windows. So this helped our real estate developer design space that was more appreciated by tenants, improving the quality of the space. And last but not least, we can, let's not forget the value of connecting our digital twins with our energy management system. We estimate that through visualizations and better analytics that we can reduce the need for energy consumption by up to 30%. By combining space utilization data with temperature, CO2, and air moisture data, we can get a better overview of how the buildings are used and running. This combination of data enables us to make better decisions for managing and distributing resources throughout the building. It also makes operational technicians and engineers more precise in managing and responding to tenants' service tasks. So in conclusion, we create scalable digital twins with business value through LiDAR scanning first and creating BIM later, giving us a pragmatic approach to lifecycle management. We generate business value through space optimization and data-driven real estate development, and finally, energy optimization.
Very good. Thank you, Timothy.